Hello everybody, in this video we are going to continue our discussion on the Earth system, especially on the Earth's atmosphere. Okay, so the Earth's atmosphere is measured from the Earth's surface all the way to some hundreds of kilometers above the surface of the Earth. And you have to understand that there's no distinct top of the Earth's atmosphere because all the air that we have here that blankets the planet, it actually becomes less and less dense as you go upwards and eventually merges with the empty space. And the atmosphere consists of layers of gases. As you can imagine in this illustration right here, we have 1, 2, 3, 4, 5 layers of gases that are held in place by the gravitational force of the Earth. And it is important because it contains life-dependent gases such as oxygen and carbon dioxide. So where all of these gases are coming from? Okay, so that is the big question, the origin of the Earth's atmosphere. And most scientists believe that volcanic outgassing that occurred, during the early Earth was responsible in transferring various gases from the Earth's interior, from the deeper part of the Earth, all the way to the surface of the Earth. Okay, as illustrated by this picture right here. Okay, and these gases include, hydrogen, helium, carbon dioxide, nitrogen, and water vapor as well. And if you travel and if you observe the processes that are happening in some volcanoes, for example, volcanic outgassing is something that is very common, and it is still going. It is still going up until today. Okay, so for example, here is the sulfur-rich gas that was released by Mount Ijen in Indonesia. Okay, so Mount Ijen right here, as you can see here, produce lots of clouds right here, and these are gases that are being transferred from the inner part of the Earth all the way to the surface or into the atmosphere of the Earth. Okay. Another thing that I would like to highlight is that I don't know if you noticed that, I mentioned hydrogen, carbon dioxide, water vapor, ammonia, and nitrogen, but I never mentioned anything about oxygen. Yet, we all can agree that oxygen is such an important gas in our atmosphere, right? Because every living things require oxygen. Well, most of them, okay? So the big question here is that where is oxygen? Where is it? Well, first of all, you have to understand that, during the early Earth, the atmosphere of the Earth at that time was very, very warm and hostile. Okay, it actually did not support. It could not support. Life on Earth at that time. Okay, the reason for that is because the atmosphere consisted predominantly of greenhouse gases, such as this guy right here: carbon dioxide, water vapor, ammonia. These are examples of greenhouse gases, and these greenhouse gases made the early Earth's climate to be very warm and hostile, and that is the reason why no living organisms could live at that time on Earth. Okay. So how did the oxygen of the atmosphere form? Okay, or how did the atmosphere of the Earth eventually receive oxygen? Okay, so most people or most scientists believe that nitrogen and oxygen added to the atmosphere at about 2.4 billion years ago, and that contributes to the one of the most significant event of atmospheric evolution of the Earth. Okay, and most scientists believe that cyanobacteria, the presence of cyanobacteria at that time, was the one that caused the increase of oxygen in the atmosphere. And we have to understand that cyanobacteria requires photosynthesis, and we know that photosynthesis takes CO2 from the atmosphere, plus sunlight as well, and this process will produce oxygen. Okay, so cyanobacteria was the one that released lots and lots of oxygen into the Earth's atmosphere at about 2.4 billion years ago. But how do we know all this, right? These processes were not there were no people who witnessed these processes. So how do we know about all of this? Okay, and that's where geology, the role of geology, becomes such an important thing. Okay, because in geology we study rocks, and this is one of these right here. This is called the banded iron formation, and this banded iron formation has about 2.4 billion years old. Okay, so the age of this banded iron formation is about 2.4 billion years old. Um, these banded iron formation forms in a marine environment right here. Now, when these rocks form, it actually reacts with oxygen. Okay, the reason why we call it banded iron formation, because of course it has a lot of iron in it. Okay, and if you have iron plus oxygen and these two reacts, the process is the rusting of the earth. Okay, as you can see here with this color of this banded iron formation, you can see that it's rusty color. Okay, the reason for that is because during the formation of banded iron formation, the iron within these rocks reacted with the oxygen in the atmosphere, indicating that at the time the formation of banded iron formation, there was lots of oxygen in the atmosphere, allowing the changes of color in these rocks. Okay, so that's how we know that the Earth's atmosphere evolved at about 2.4 billion years ago, when oxygen levels started to increase in the atmosphere. And eventually, this is what we have in the Earth's present day atmosphere, right? In present day, we have nitrogen, which is the most abundant gas in the atmosphere. Okay, it is nitrogen, not oxygen. Oxygen is actually on the second place right here, with about 21% of the entire atmosphere. Now, if you add the two numbers together, 78% plus 21%, well, about 99%. So the rest, the other gases, make up about 1% of the Earth's atmosphere, and these gases are listed over here. Okay, but I would like to highlight these gases that are in this yellow box right here. Okay, these are greenhouse gases, and greenhouse gases keep the Earth's climate from being unbearably cold. Okay, now later on we will learn about climate change later on, but I have to say that when we learn about climate change, we will learn about greenhouse gases, because these greenhouse gases can keep the heat from the sun in the atmosphere, creating an elevated temperature condition in the atmosphere. Okay, but my point here is that the Earth still needs greenhouse gases, because otherwise it will become so cold. All right, the next thing that I would like to talk about is the Earth's the structure of the Earth's atmosphere. Let's start with the general concept of the Earth's atmosphere, that again it is up to 480 kilometers thick, and the solar radiation interacting with the Earth's surface and atmosphere produces thermal structure that we can see here, creating 4 atmospheric layers. Okay, that I will be talking about in the next few slides. And I will be talking about the first one, which is called the troposphere. Okay, the troposphere is at the base of the Earth's entire atmosphere, and the temperature change in troposphere is that the heating of the Earth's surface by solar radiation, it causes the temperature to cools upward. As you can see from this red line right here, it drops to the left, meaning that as you go upward towards the upper part of the troposphere, then the temperature will become less and less. Okay, this is one of the layer. This is the layer of the atmosphere that support lives. Okay, and weather occurs right here, and we have clouds as well. And this is the level where airplanes typically fly. And the next one is the stratosphere. The stratosphere increases, the temperature in the stratosphere increases upward. Okay, and there's an important layer that is present here in the stratosphere, which is called the ozone layer. Okay, ozone is O3. Okay, that's the formula for ozone layer, and you have to understand that ozone is such an important layer for the Earth because it protects us from the ultraviolet light, okay, from the sun, or the UV light, which is very harmful to human. Okay, contains ozone layer that protects the Earth from the harmful UV radiation that causes sunburn and skin cancer. Okay, so if you went to the shore this summer, for example, you needed to put some sunscreen in order to lessen this this effect right here. Okay, so those are the important layers of the Earth that I would like to just mention in this brief explanation of the Earth's atmosphere. We're going to be talking about that in more details in future modules, but for now I'm gonna stop right here, and then there will be one more video about the Earth system before we wrap up this material. Okay, I'll see you in the next video. Bye bye now.